So if you guys are expecting to see Takeo, he's probably on the sheet. His picture name is. He had a family emergency, so me and Jason kind of hopped in late last week, figured out we needed to, get this done. With that being said, it's kind of two PowerPoints kind of merged together, so some things might be off a little bit, but I've done something similar like this multiple times. But we are going to be covering the surgical microscopes, you're typically going to see in your OR, surgery centers, even ENT clinics, and then I doubt that many of you do, but go into like any of the endodontist, anything like that. So I'm going to go ahead and get started, with the slideshow here. Three most important things to know about the surgical microscope, what the doctor's going to be looking for, are the good optics, vision. That's what you want to be able to see. And that's what the optics help you do. The light, they want good light, they want bright light, and they want clear light. Depending on what they're doing, typically it's going to be the whitish, bluish light. Some doctors, when you get into ophthalmology and an ENT, they like that yellowish halogen light. But majority of the time, they want that clear light. Balance, most of the scopes, they move around. The doctors need to move them around, and they want to be able to move around and just stop into place when they let go, but be able to move it when they want. That's all balance, and I'll kind of get into that as I go. These are just parts of the microscope head. Actually, I have one here too. I'm more of a hands-on person. Like, I actually taught for a couple of years. I always like to have things in kids' hands. It's actually taught a variety of ages. So if you guys want, I don't mind passing this around. So you can see the different labels on here. The camera adapter is going to come out on the side of the beam splitter, and these are the binoculars. You have the eyepieces, the objective lens, and on this one there's actually a bridge instead of the beam splitter. So you'll have the main doctor looking through one side, and the assistant looking through the other. And then there's an observer. So depending on what kind of case it is, sometimes the observer for eyes are just the assistant, the technician, they're just handing over the tools if they don't have video set up. Or for brain surgeries, that's actually another doctor typically. So you have a doctor side by side, or a physician's assistant, depending on the complication of the case. But that's just the part. And if you guys want this forwarded to you, if you guys really do a lot of them work on the microscopes, I don't mind sending you the PowerPoint. So if you want to ask me afterwards. Again, these are different attachments to the microscope head to help with seeing. That top one on the left, I always call it the pirate one because it is just a mono. It's just one you have to close one eye and look through. That's usually for teaching. Usually a student's looking through, watching the case. Then you have the top of the beam splitter. You can see that there's two holes. The next one is a camera that it would attach right to the camera adapter. And then the beam splitter, it's a Zeiss beam splitter. And if you see those little numbers, it says 50, 50, it says 50 on it. That means that the light is shared 50-50. So the doctor will see 50 and then 50 goes out. That's really old. Now they're all like 80-20. And I think even a Leica ones that those small, so 70-30. So the doctor wants majority of the light. On the one on the bottom here, that's kind of an eye scope from Leica, and that actually has 4 holes. It's a quadplex. So each one of those assistants or observers has 2 different holes. If you guys see what I'm saying on that. So I wish I had a picture on there, because a lot of times those will get out of alignment. And if one gets out of alignment, then no one can see. So it's usually a quick fix of just loosening up the set screw and putting it in all place so all 4 holes line up. Those are the different binoculars. You can see that you can't see on there, but high incline, 0 to 180. And usually I'll say like right on here, like this is a 0 to 180 because it moves 180 degrees. So if you go from one side to the other. There's 0 to 60, Leica has a 10 to 50. They're all different degrees. The one thing that we look for too, and this might be in the most common issues. These are like on the Leicas. There's these rubber bellows that get torn or ripped, and then dust gets inside there and they need to be cleaned and replaced. Quite often, size doesn't happen. Parts of the binocular itself. The main thing on here is the pupil distance, and that is the distance between your eyes. Doctors adjust that all the time. If the doctor is grabbing this over and over, sometimes this will get out of alignment. You have to pretty much exchange the entire binocular. The other piece is the eye cup. Most of these eye cups come right off. They're usually lost or torn all the time. So those are replaced about every couple of years. Every time you guys should do PM, should look to see if those need replaced. These are just different eyepieces. They range, I know you guys can't see it, the one at the top is 20 times and it'll go all the way down to 8.3. But on here is the diopters. So each eye, if you have glasses, you might know if you're a +2 or -2 or +1, -1. The doctor can take his glasses off and switch it on here, so he doesn't have to wear his glasses. But if they are wearing glasses and they have 20/20 vision, it needs to be right on the 0 mark. There is a 0 mark on there.
A lot of times if you have a doc or surgery complaint about a blurred image, but they are getting a good solid image, sometimes they'll have one of the doctors set too far or not the same as the other, so they'll actually create a little bit blurred.
Yeah, and sometimes they'll say they're cross-eyed because the depth perception, because it'll actually, like you see in this one, it'll actually pull, it moves in and out as you turn it. So if one's all the way in and one's all the way out, they're looking at that much difference on each eye. More parts to the microscope. The bottom's the base, stand column. This is really good to have if you guys do have somebody in the OR who's calling and says, hey, the arm's not moving. Well, which arm? It could be the suspension arm, the swing arm, or even this extension arm, which is the optics carrier that's actually holding the head. But this scope actually has like a control panel on it. Not all scopes has a control panel or a monitor attached. Like I said, there's a swing arm. The suspension arm is what goes up and down. The swing arm swings. And then there's typically an XY, so the head will just move in a very small area without moving the entire scope. Mechanical brakes. And all these brakes, besides the floor brake is either on or off. It's usually just a stomp or a double click to pop it back out. But all the brakes on the arms are friction brakes. So the tighter you have them, the less likely it is to move. But if you loosen it, it'll move. That little note on there, I think that really depends on the doctor and the case. Because a lot of doctors, if they're doing an eye case, will just swing it out. But like an ENT doctor pulls it down and moves the entire scope. So if you have one brake tighter than the other, then that whatever's the loosest will move the most. But I have seen where doctors will put it into place, tighten all the brakes, do their case, and then try to move it. And that's usually when brakes go bad because you're wearing off. A lot of them are just brass or kind of a rubber or a padding that gets worn down. The other brake is the electromagnetic brakes or clutch brake. So they would be able to control it with their hands. So as soon as you engage the clutch or the brake release, it can move around, and wherever you let it go, it just stops and you can't move it. And then on some of the scopes, I know like a lot of the size scopes, there's even a button on the suspension arm that you can push. That's more for like staff to move the scope around, especially if there's a sterile drape on the head. And you need to move it. It's kind of a simple one on these scopes, on the basic scopes. There's just a 6-step magnification, and then focus is anytime you want to. It's pretty much the doctor either getting closer or farther away. Like on an ENT scope, this has a 250 lens. So at 250 millimeters, perfect. It's parfocal, perfect. Perfect image. But if they want to go a little bit deeper, that means they need to change their focus. So like on this one has a fine focus lens, so this will change it like 15 millimeters. But if they're adjusting a lot, this knob right here moves the entire head, pretty much a couple inches. So you're looking more. So that's what that focus drive is doing. Pair of different light sources. Typically, picture, I'll start here. So this, the one in the upper left-hand corner is pretty much an obsolete light source. I mean, it's an 1880 Dionix light source that it's about 30 to 40, maybe more years old. We've been typically replacing those, upgrading those. But the next one is a xenon halogen split. So a lot of eye doctors, depending on the case, will use a halogen light source, but then if they have the same scope, they'll use the xenon for a different case. So that's common in more eye scopes, or even in some ENT doctors will have that, and halogen will be the backup. The next one is an older xenon light source. It's a size Super Lux 40. There's a Leica. That's a small LED that's built inside their ENT head, or it could be a dental head. The Superlux 300 is pretty similar to the 400. They actually both take this same bulb. I think you guys are probably familiar with these because there's a lot of different light sources that take these little 300 watt xenon modules. The next one is a Prescott halogen light source. That's what we usually upgrade those older ones up to. You can tell that's on the same post. We'll just put a brand new halogen light source and try to repair that one. And then this one is a LED. This is a 60 watt LED, which can typically only be used for ENT, simple spine. I put this on spine scope before, but it cannot be used for eye. Ophthalmology is typically only used with a halogen light source unless they have it filtered for the xenon. I think that's my part.
All right, so I am going to just talk a little bit about the different disciplinaries and what scopes are typically used. You'll see them in the hallways and what practices they're usually used for. So first, the ENT scope, pretty basic scope. Typically, they're always going to be a mechanically braked or mechanically controlled stand with, as Clayton mentioned, a smaller LED light or halogen. They also convert an ENT scope into an endodontist scope, and you can see by adding a wedge, this actually creates a situation where the scope can look straight down, and the doctor can be positioned ahead. And you guys probably don't deal with dental all that much, but it's actually becoming very popular for back issues. A lot of dentists are complaining about back issues, always have to be bent over, but this puts them in an upright position. So that's really the difference between an ENT and scope is the wedge. These are going to be more spine and neuroscopes. They're going to be a lot larger. These are going to be the electromagnetically clutched brake stands. They're all going to have typically a main surgeon, an observer, and possibly another assistant. Another telltale sign is you see pistol grips with hand controls. So instead of the manual controls, the magnification and the zoom on the manual, all of that is controlled by a hand grip switch. So some typical things that happen with these type of hand grips, this is a Zeiss hand grip. You'll see this on a Pintero, you'll see this on Sincera, Promagus, I think, and a couple other ones. Some of the issues that can happen with these is the toggles, and it's hard to see their toggles for zoom and focus here. They actually get sticky or they'll stick, which happens during a case and it zooms past or it zooms beyond where the physician wants to be, and it drives them crazy. So we actually do a grip insert replacement, so we don't have to replace this entire thing. It's just a grip insert. We can get that replaced pretty easy. It also controls their XY movement. So anytime they want to do small increments, north and south, east and west, they will have the XY movement button, and hard to see it here, but it's there here. And also accessory buttons, they can be programmed to function light up, light down, camera, and then some of the larger ones like a Pentero spine scope can do an autofocus where they won't even have to do manually focus, and they just hit the button, focuses right where they need to be. And typically they'll have a control unit with a monitor of video so that the surgeon can record or take stills of the cases. These are the ophthalmology scopes. Typically you'll see Zeiss and Leica and then Alcon as well. But with these, the two that you see here, one is electrically controlled and one is manually controlled. You'll see, as Clayton was talked about a little bit earlier, the surgeon can use the electromagnetic brakes to position the scope, let go, and it stays there. However, if the head is already draped prior to the case and somebody has to get in and make any type of movements, this is this bar, brake release bar up here on the top of the flex arm. You actually push that and actually move the whole entire head around without touching the sterile field. And then let's see. So typically with an eye scope, some of the more common issues is going to be balance of the scope. Once the physician gets the scope in place and goes to do something, if it drifts away from him, falls, it's just a balance issue. Anytime you do any type of reconfiguration of the head, if they're adding an assistant scope on, if they're adding a camera adapter, it adds weight to that head, and so everything needs to be rebalanced, especially in between cases. If they're doing a retina case and then they go to a cataract case, or whatever they're doing, if they're changing configuration, they always want to rebalance that microscope. Another issue is light intensity. If the surgeon or the doctor is complaining about not having a bright image, first thing to check is fiber optic cable. A lot of times at the ends where it goes into the head or comes out of the light source can get tweaked, and that actually breaks the glass fibers in the cable. And a really kind of neat way to check that, if you want to just do it in the field, you can actually pop an eyepiece out, and while the light source is on, take the other end. Let's, for instance, this was in here. Take this other end and run it through the eyepiece, and you'll point and it'll show you a circle, and it'll have all of the fibers that are broken will be blacked out. So if you've got a fiber optic cable that is 50% blacked out, you've got a bad fiber optic cable. So that's one way to just to check it in the field, kind of easy to do. Another thing would be if the cable has been pulled out or it's not actually seated into the head far enough or correctly, that can cause light transfer issues as well. And then, so as Clayton said, they kind of meshed two presentations into one. But some more common issues that we see, maneuvering the stand. If the stand is spinning as you're trying to push it down the hallway, or you've got a caster that's locked up, typically it's got hair and grime, grease, and like thread and everything bunched up. You never, the casters are gross. So anyway, replacing the casters. If the doctor is complaining about blurred vision, as we mentioned before, main thing to check is the diopters. Make sure the diopters are set correctly, that they're getting a good, crisp, clear image. Making sure that the bino is seated and tightened correctly. A lot of times this little thumb screw will come loose, and then you've got a bino that's just not seated perfectly, and it can actually cause blurred vision. So just these are just little things that you can double check, making sure that that's seated. And then on the way through to the objective lens, you can look for stains or grime or anything on the objective lens that needs to be cleaned off. And a lot of times with the ophthalmology scopes, they'll use that a BSS solution, and it'll actually can sometimes spray up and contact that objective lens. On the newer objective lenses, they have what's called an apochromatic coating, and if that BSS solution stays on there long enough, it'll actually eat that apochromatic coating away. What that will do is actually cause some focusing issues, and it causes them to lose the red reflex that they look for when they're doing cataract in the eye. So
making sure that the objective lens is clean of stains and debris is a good.
What is BSS?
BSS is a solution that they use. I think it's like a irrigation solution that they use during cataract cases. So they'll actually be squirting that solution into the eye. Sometimes it can kind of pop up onto the objective lens. All right, some more common issues. Foot switch controls are unresponsive. So on ophthalmology scopes and plastics, hand plastics, neuro, some of the spine folks will use a pedal at different times, but you'll find that you'll have unresponsive functions. That could be a whole amount of things. It could be that the specific way that pedal is configured for that surgeon has got something messed up, or it's not on that specific surgeon's profile. So each surgeon can have every button of that pedal perform a certain function, and they can customize that. They'll always have kind of your standard user function, and then you can put in the specifics for the surgeon. If they get a function that isn't working, then it could be either a setting or it could be something on the foot control, a switch or something in the foot control that's not responding. We typically will take those in and do a quick exchange. We have a facility in Colorado Springs that have techs that are doing nothing but refurbing parts, pedals, XYs, different things like that. So typically when you get a foot switch control that's not responsive, it's either going to be a setting or a switch issue. Cable management, as far as cable management control issues, controlling the microscope, having a cable that's either pinched or hung up somewhere can cause the electromagnetic clutches not to work correctly. Or if it is a manually balanced scope or manually braked scope, if the cable isn't routed, you'll have surgeons that spin it and they keep spinning it because they can't get it to go far enough, and then you've got broken fiber optic cables and broken wires and everything else. So those are really, the cable management comes into play anytime they've got configuration issues or things like that. Some more light, obviously bulbs can go out, bulb life expired. Also the fuses, there's definitely bad bulb plugs. All of the bulbs go into typically a module, so something like this, and you've seen these small 12 volt 100 watt halogen bulbs. They'll go into like a ceramic connector. That ceramic connector can break, all kinds of different things, and we have solutions for all of that. If you ever get into an issue where you've got one of the older light sources and you can't find a bulb, typically we'll have it. More common issues. It's funny, they all say the most common issues, but more common issues, brakes not holding. As Clayton mentioned, with the manual braking, it's typically a brass sleeve around the shaft that they tighten up, and then that locks the stand in place. Over time, that sleeve can break, and that will either not allow them to lock the stand, or it will actually wedge, and you won't be able to move the stand at all. So we'll just do a quick brake replacement. Surfaces can get worn out. Accessories are loose. That's something I just mentioned here. Making sure all these thumb screws are tight, and then any accessory ports on the side. Just making sure everything, all these connections are tight. So some of the troubleshooting checks, just to check for light transfer, check power supply for damage, cable, cords, the power supply of the stand itself. If you're having maneuverability issues, if it's an electromagnetically clutched brake, it could be power supply or any type of cabling that runs through the stands. Let's see, brakes to ensure device maintains position during procedure. Again, we talked about the electromagnetic and the manual brakes. Tight connections for all the accessories, making sure everything is tightened up. Damage to any of the cables or connectors. A lot of times they'll have a connection underneath the microscope for AV or for video, and if they're moving that scope into another room, sometimes they'll forget and they'll pull that AV cord right off the bottom. Making sure that the debris from the old plug is out and cleared out, because I have gone in quite a few times, and they're like, this just doesn't connect up correctly. So light source issues, and then the manual electronic controls. Some more of the complex issues that we've run across, no focus, no zoom, and depending on the microscope, those could be zoom and focus motors. They could be boards, they could be OPMI boards, OPMI control boards, bad connections. We've got a lot of different issues that Prescott is actually available to take calls and to help with. We do over the phone support, or your local rep can come out and take a look, or you can contact them over the phone. Just a little bit about Prescott's, and I know we're not supposed to make shameless plugs here, but it's here. We have a variety of solutions that we offer. I'm actually the Chicagoland area rep. I do come up to Milwaukee quite often to help out Takeo, and I'm going to be doing that more here. Clayton is down in Indiana. We actually can come in and do no-cost inventory evaluations. We can come in and do evaluations on scopes. We'd have video solutions, rental options, component upgrades, whether it be light source components or camera upgrades, and scope refurbish. We're one of the only companies in the world that actually are ISO certified in refurbishing surgical microscopes, and that's all we do is surgical microscopes. We actually have our facility in Colorado Springs, and every microscope that we that goes through our refurbishment process is ISO certified, like new. It comes with a 2-year warranty. So we give you actually an added year outside of what the OEM offers, just to make sure that you know, everything is covered there. We have a manufacturing plant, so any type of old equipment, we actually do manufacture a lot in the machine shop that we've got for some of the stuff that you can't buy anymore. So we actually have a machine shop that we can manufacture things, and we do have an international presence as well. This is other stuff.